I've been doing stuff with Linux for 20-something years. And when Android came out, I thought, hey, Android is just Linux. It's just embedded Linux with some funny Java stuff on top. So I started doing Android as well. I've written a book about Linux, mastering embedded Linux programming, just saying it's a book out there you can go and buy if you wish. And you can contact me in various ways on Twitter, LinkedIn, and such like. So we're going to be talking about what's underneath the hood. How does Android really work, insofar as I can, within 40 minutes. So first of all then, ADB. So this is the tool we use for developing Android. You can't do anything, any Android development without ADB. What is ADB? It's actually 3 different components. There's a thing called ADBD, the ADB daemon, which runs on the Android targets. The ADB daemon is talking to the ADB server, which is running on your development machine, your laptop or whatever. And the connection is usually, most often, a USB connection, but it can also be a network connection because it just works over a TCP socket as well. And then thirdly, you can also be running an instance of Android in an emulator, in which case ADBD is talking to the ADB server over a Unix socket, which confusingly is given a 4-digit number, but it's actually a Unix socket. And then the component on top of this is that we have the ADB client. So this is talking to ADB server on some port number or other. And for the purposes of this talk, we're going to be using the command line ADB, but it could be Android Studio or any one of a dozen other Android tools. And then I'm going to be using screen copy, mostly because I want to show you some things. I want to show you the screen on my phone as I'm doing things. So I'll be using screen copy just to give me a remote copy of that. And come back to that in a moment. So let's have a just quick look and see what we've got. So that's my phone. And that, whoops. So I'm going to connect to my phone with ADB. So, well, first of all, ADB devices. So you can see actually I have 2 devices. The one with the meaningless serial number is my phone, and the other one is the emulator. So connect to the phone, -D for device, whoops, shell. There we go. So you can probably tell from the code name, BlueJ, is a Pixel 6A. So what can we do? So first of all, we want to know what is this that we've got. So a couple of things I can do. So I just want to know what version of Android is running. Hope I get this right. I didn't. Okay, well, there was another way of doing it. Yep. There we go. So if you can't remember exactly what the variable is, just do the whole lot. So I'm looking. So getprop dumps out the system properties. System properties I'll talk about in a little while. But for the moment, I'm just looking at the ro.build properties, and that tells me about the build. And somewhere down here, which I've forgotten, is the version number, which is 13. There it is. Release, that was a bit I was trying to remember. So we're running Android 13, and probably the most interesting bit here is something called fingerprint. So that's that little bit up here. So that says Google, BlueJ, TP1A, blah, blah, blah. That's the build ID, and it's a user build, and it's using release keys. Okay, loads of useful stuff there. Also, what version of Linux are we running? So uname will do that. Uname -A. and we're running 5.10 build, which isn't the very latest Linux, but it's pretty good. Okay, so so what is Android? Now, we don't really have time to ask everybody here their opinions, but Android is different things for different people. So I'm going to tell you what I think of Android, or what I think Android is. So if you are just an end user, then Android is just a bunch of applications. So it's the top layer of the cake. Oh, by the way, I should have said this is a 4-layer cake, in my opinion, mostly because I just like cake. So but if you're writing applications, then Android is an API. So you'll be coding stuff and you'll be using Android APIs of various sorts. Those APIs then, so those APIs are implemented in a jar file, in a Java library, which is installed on the device. But when you make a function call to Android, that doesn't actually do the work. The real work is done by the level below this, which I call system services. So Android is a collection of system services, and these are doing the actual work. I'll come to that in a moment. And the communication between the library and the services is done through a communication mechanism called binder. So the system services and the library are written in Java, mostly, some bits in C++, but mostly Java. But at the lower level below that, we have what I call the glue libraries, and these then allow the Java components to call down to the native layer. So the native layer, this contains basically a POSIX Linuxy type environment. So it contains a lot of daemons, especially the init daemon, which starts everything off. The hardware abstraction layer, the HAL, which is also a bunch of daemons, and a bunch of libraries. And then these, in turn, are calling down to the layer below that, which is Linux. So everything eventually ends up with Linux, because Linux is the thing which makes things work. The kernel layer, the Linux, it's a pretty standard Linux kernel these days. Last time I checked, there are about 200 patches on top of mainline Linux, which may sound a lot, but actually it's not. It used to be thousands and thousands of patches. So the Android Linux kernel and the mainline Linux kernel have been converging over the last 5 or so years, which is good. So let's talk a little bit about these system services. So Android is an object-oriented operating system implemented on top of a POSIX operating system. So the POSIX operating system essentially is Linux, but in the Android framework, we have these system services, which are essentially Java objects, and they can pass Java objects between themselves in terms of binder parcels. So this is where the work really gets done. The system services are running in a separate environment to the application. So they are running with a high privilege level. They actually have user ID set to system, which is 1000, which allows them to do many things. And also they have full access to the framework APIs. So they can basically do anything that Android can do. So the way it works then is basically Android applications are sandboxed. They can't do anything. In order to do things, they have to call the framework, send a message to the appropriate system service, and then that will do whatever it is you want it to be done. And we can look at this from the command line using things such as service list and service call. Excuse me. Couple of notes about binder. So binder is an IPC. It's an inter-process communication mechanism, a little bit like a socket. So the way it works is like this. So your application, you make a function call, for example, set content view. That function call is in a library called framework.jar, which is in the system framework directory. Excuse me. So that's the function call. But then in framework.jar, you're in a component called activity manager. And that's going to send a message, a parcel, to via binder, /dev/binder is the kernel binder driver. And that will then be received by the appropriate component in the system server, which is called activity manager. A little star there. You note from my comment above that actually we have managers send parcels to services. They don't always follow the naming convention, so the bit in system server should really be called activity service, but it's actually called activity manager. Excuse me, I've got an attack of the coughs. So yeah, let's try some of these things out. So there's my phone. Whoops. And I have some cribs here because I can't reliably type things in without getting it wrong. So let me just go to my crib sheet. Okay, so first thing I want to do, come back to here, is I just want to get a list of system services. So I type service. Where's it? Try that again. Okay, that doesn't look too good. Let's do it again. Okay, so 278 services. That's way too many. So if you go back just a few releases, there were like 60 services. The number of services in Android have been increasing release by release. Actually, a load of these things are not really services. So if I just come over here for a moment, anything beginning with android.hardware, so all that android.hardware.com stuff, those actually are part of the hardware abstraction layer. They're part of the HAL daemons. So not really services at all. But yeah, there's loads here, so I can't go through all of them. Whoops. Yeah, so I just want you to give a quick example of one. So once you know the name of a service, you can talk to it. And we can talk to it either using dumpsys, which just dumps out the current state of the service, or in some cases we can interact with it using CMD command line. So example of the first one, I can do dumpsys CPU info. And that gives me basically some scheduling stats of the CPUs. Quite a lot of it. There we go. So it tells me what's been active on my phone for the most recent second or something. Excuse me. So yeah, okay. I'm not going to go into that in any more detail, but hey, there's some stuff. The next thing we want to look at is, yeah, okay. This isn't going to work quite so well. So I can also do a dump. There's something called the display manager. And the service is just called display. So that gives me a whole bunch of information about the display. It should tell me useful things like the size of the display. Again, there's basically too much information here. Yeah, okay, I can't find it. But I can also use the CMD to display. A bunch of things I can do with this, including set brightness. So that's the first thing, that's the obvious thing to do. So I can do CMD, display, set brightness, and then a number, 0.5, for example. Or 0. So that turns the display black. Unfortunately, this doesn't make very good demo because screen copy doesn't take any note of this. So you just have to believe me, my screen's gone blank, really. You can send a representative around here if you want to kind of validate that. I don't mind. So I'll turn that back up to something that's reasonable so that I can see it in the dark. Okay, next thing I can do. Again, go into the cribs. Yeah, right. So, I would like to make a phone call, but I don't want to use the screen. That's way too boring. I want to make a phone call from the command line. How do I do that? So first of all, I need to know which service is handling that component. I happen to know it's one called phone. So if I look for phone, oops. There we go. So we see there is indeed a service called phone. It's this one here. So I'd like to send a message to it, and I can do that using the service service call. Excuse me, call. So, but I need to know what parameters. And for that, we notice that most services have an interface. So this is an AIDL interface, iTelephony. So I need to know what does that do. Unfortunately, you need source code for this. So we're going to do a lookup. Oops, that one. So I'm going to this website because I want to do a search for a file. And the file I need, if you remember, I want actually iTelephony. So iTelephony is a file somewhere in the Android source code, and I want the AIDL of that. So if I type I, good, that works. So this takes me to the file. So if I had the Android source code available locally, I would do this as well, but I'm doing it this way. Oh, okay, I wasn't expecting that. There we go. So this is the interface to the phone app. So we see it has an interface. The interface is indeed iTelephony, as I just said, and as the file is named. And now we look at the functions that this interface exports. So we have one here called dial, which will, as it says, dial a number. But it doesn't place the call. I actually want to make the actual phone call. So I notice the second function is called call. Takes two parameters, two strings basically. The second string is the number you want to dial. Okay, so with that information, I can now use that function. Come back to here and to here. So actually, a service will do for the moment. V-I-C-E, yeah, there we go. So with the service call, I give the name of the service, the code, so that's the number, 1, 2, 3, etc. I want function number 2 in our case, and then a bunch of parameters. So each parameter you need to prefix with the type. So we have strings, and that's represented by S16 because these are 16-bit Unicode strings. So I can do this. Service, call, phone, function number 2, first parameter, string. I know the parameter doesn't actually matter, so I'll just put test there. And then the second parameter is the number I want to call, 1, 2, 3, 4. There you go. And it's making the call. And I don't know if you can hear it, but it's saying, you have no voice messages. That's not working. Believe me, it does work. Okay, so if I know the interface name, and the interface number and the parameters, I can do pretty much anything from the command line. Now, not pretty much anything. The main restriction with service call is you can only send strings and integers and floats. It can't pass Java objects because nobody's come up with a user interface yet which allows you to construct an arbitrary Java object from the command line. So if anybody wants to do that, there's a gap in the market, but it hasn't been done up till now. But yeah, service call, great little thing. Yeah, okay, let's move on to the next topic. So I've got a couple of slides about two particular components, system services, package manager and application manager. So package manager is a system service, so I can do a dump sys package manager if I want. And it's responsible not only for Android packages, but also permissions, system features, platform libraries, and probably a few other things as well. So we can access this through dump sys. It also has a command line tool, CMD package, and it also has its own dedicated command line tool called PM, which is short for package manager. Just a bit of background information. When you run package manager, or when you install an Android package, package manager records this information in data system packages XML. So that's its central database. And we can dump that using things like dump sys packages. That will just give us basically a complete dump of it. And we can also get a slightly more constrained version of that information with PM list. Activity Manager is another system service. So this is responsible for basically running everything in Android. Activity Manager is the Android scheduler. Everything that happens at the application level happens because of Activity Manager. And we can dump sys it, we can use logcat. We can use logcat minus b event. I'm not going to do this, but logcat is logcat, you know that. Minus b event will dump out the event buffer, which gives you the log information relevant to Activity Manager and the Android runtime. And it also has its own command line tool called AM, short for Activity Manager. Okay, how are we doing time-wise? Yeah, okay. Probably need to speed up a little bit. So let's just have a quick look at a couple of those things. Again, I'm going to refer to my crib sheet. Okay, so I want to launch the desk clock, just some Android application. So I go copy that. That happened before. That is because it is actually called Google. Okay, so this is the package manager entry for the desk clock. So it's actually called google.android.deskclock. And right now I'm looking for the intent filters, and I particularly want to know what the action main is, because I want to start it. So there it is. That's the main entry point. I need to, oh, it's not going to work, I remember. Do that. Do that again. So action main is that action, that intent. So now I can use AM, start activity, and give it that string. Now, do that. Doop-a-doop. And yeah, it works, of course. So that was sending an intent, starting, in this case, the desk clock. I'm bored with it now. I want it to go away. So I can cause it to crash. So AM crash. And I just need the package name in this case, so we can get rid of all this junk. That look good? Yeah, there we go. And it crashed. And I could look at the logcat, and we could see that it did indeed crash, and we could look at the yeah. Wouldn't be that interesting because we know why it crashed, so maybe it's not so handy. But hey, you can do that. Okay, next topic. Okay, so that was looking mostly at system services. Let's look a little bit at native services. So this is the layer below the Android framework. So the native services, these are basically Unix daemons. They're started by the init daemon at boot time. And they're doing low-level stuff, as we'll come to in a moment or two. So the boot sequence is you power on. When you power on, you run a bit of code called the bootloader, something like little kernel or maybe uboot, which is then going to load Linux. So that loads the Linux kernel into memory, sets it going, Linux boots. At the end of the Linux bootstrap, it runs the init program, /init in this case. So init is then part of Android. So the init program then runs, it parses various files, and then it's going to start Android. Important daemons include ADB-D. We know that already. That's doing the ADB communication. The log daemon is what is recording the logs that you see with logcat. Zygote I'll come to in a moment or two, plus some others which you can read on the slide. So this all starts off then when the init program runs. The second stage init program actually is called system bin init, and it actually does the second stage boot is the main bootstrap. It parses a whole bunch of these .rc files. RC stands for a run command. And the master one is this one here, system etc init hw init rc. So that's the one that everybody has. And then there are a whole bunch of others that come along from that. Let's have a quick look at these things. Yeah, comes I get a moment. I'm going to switch to the emulator at this point because some things that I want to do I won't be able to do from my phone. So do ADB shell -e for emulator. First of all, then let's look at these RC files that are being parsed. So if I do that, so as you can see the whole thing, I'm doing a logcat, buffer kernel -d pipe to grep, and well, actually just more will do. More, yeah. And it helps if you spell things correctly. So this is the this is the early part of the boot. This is all the Linux bootstrap you see here. Right. So if I do the same thing and now do a grep, parsing. Okay, so these are all the RC files that the Android init program parses when it starts up. Starting with the master one, which is that one. So that contains the generic stuff. There's one here called init ranchu. Ranchu is the code name for the emulator. So that has initialization specific to the Android emulator. And then you can see that there are init files further down which do all kinds of things. Boot animation I can see, and yeah, tons of stuff. Altogether, there are about 120 of them. So each one of those is starting up one of these native daemons, and altogether these make Android work. One of those daemons is Zygote. In fact, probably the most important one is Zygote because this is the daemon that starts the Android runtime, ART, which allows you to run Dalvik bytecode. So I just want to do a quick demo of this, but not from there. Get rid of that. So this is the emulator screen, and this hopefully is that screen. Put it there. Okay, so I'm just going to do one very quick thing. I can start and stop these daemons using the commands start and stop. And if I just type stop, start, actually just do stop by itself to start with. Must be root, of course, so type su, now I'm root. This is a user debug build, not just a regular user build. So if I type stop, that essentially has stopped Android. The screen is still here, but nothing works. Click on all the buttons, it's all dead. That's because Android is stopped. Linux is still running, I've still got a command prompt, Android is not. If I type start, S-T-A-R-T, that's better. Now it's starting Android. When it starts Android, you saw that very briefly, it actually starts from the beginning. So it runs the boot animation. The boot animation then, when that's finished, we can then run Surface Flinger. Surface Flinger loads everything else up, and now we have the full running Android. So if you want to reboot Android without rebooting Linux, you just do stop, semicolon, start. Okay, done that. Okay, we can do this. Sandboxing. So this is one of the key things, key concepts of Android, is that applications are sandboxed. And they are sandboxed in two different ways. First of all, memory. Each application has its own unique area of memory and cannot interfere with any other application's memory. And then secondly, with files. So when it comes to files, Android makes inventive use of Linux user IDs and group IDs. So the first one, memory separation, this is given pretty much for free because of the way Linux works. Every Android application is a Linux process. A Linux process is an address space represented by the box, and it contains a number of threads. You always start off with one thread, but you can also create additional threads to your heart's content, in fact. But the important thing then is that in my diagram, the three threads in the first box, T1, T2, T3, they can see each other's memory because they are cooperative, they're in the same address space. But the threads in the next box, T4, 5, and 6, these are in a completely isolated address space. They cannot see anything that's going on in the first app. So we have memory separation. The second one, file separation, is slightly more difficult to, or more involved to describe, so bear with me for a moment. The key thing then is that every Android application has a unique user ID. When you install an application, Package Manager gives it some unique user ID. So Android is using Linux user IDs actually to represent applications. The user ID identifies the application. Then every application needs some place to store its data. So that's going to be in /data/package name. And the permissions of these files are set such that only that one application with that one user ID can access these files. So in my example here of the camera, we see that by doing a dump sys of the package manager, it has been given user ID 10,080. This is on the emulator. And then if I go look into data, CALM Android, CALM Rep 2, we see that the user IDs assigned down here are, well, that string there, U0_A80 expands to be 1080. Sorry, 10,080. And so only this one application can access the files in that directory. SE Linux, I'm going to have to skip this. Talk to me about this later. And I'm going to skip that as well. A couple more things about the ADB shell. Got a couple of minutes ago. Yeah, there are three different Android builds. You have user builds, user debug builds, and engineering builds. A user build is what you get on a commercial shipping product. And with user builds, you only, when you do an ADB shell, you only get user ID 2000. User ID 2000 can look at various things, but it can't change anything. The next one is the user debug build. This is like a user build, but it includes debug tools, and crucially, it includes an SU utility. So I can type SU, that will give me a root prompt, and then I'm root, and I can do all kinds of things. And then thirdly, there are engineering builds. So these have root access by default and all the debug tools. When I'm working at the command line, I'm using mostly a component called Toybox. Toybox is a multi-core binary, and if you just type Toybox by itself, it lists out all the subcommands it implements, which includes, even down here, you spot a little VI program. So you can even use the VI editor on Android. Yeah. System properties, one slide. I mentioned these very briefly at the beginning. So system properties are a global store of name-value pairs which control Android. So basic information, status information, such as whether daemons are running or not, build time configurations, such in this case, setting the LCD density to be 420 dpi's, and also local configuration, setting my time zone in this case to be London. That's basically it then. Where next? Well, get your Android devices out and start digging. One of the most interesting things you can do, in my opinion, is to build your own Android system using AOSP, the open source project. There's a bit of information down here, although notice that it's not trivial. So if you do this, yeah, give me a call first. Finally, I'm going to do a quick plug for a couple of things. So I do all my work at the AOSP level. There isn't much community at the AOSP level, so I have set up my own community, the AOSP and AAOS meetup. Be great to see any of you guys and girls there. And that's basically it. I think we have literally 1 minute for questions. 2 minutes, okay. Question at the back. You. How do you get a user debug or engineering build without rebuilding it? The answer is you have to rebuild it. You cannot magically take a user build and turn it into a user debug build, because there's a whole bunch of additional parameters you've got to build in. So basically, you've got to do the hard work. Sorry, it's a fact of life. Someone else? User. Why is Android using init when systemd is far better? Don't know, ask Google. My guess is that since Google didn't write it, they're not interested. But that's just my opinion. But systemd would improve Android no end. Just saying, guys. Time for one more? Oh, hey, we've got a microphone. Cool,
Thank you.
I've forgotten about that. Thanks.
I've worked with AIDL before, but with apps that I've controlled, or it could communicate an app with a service of my own.
Yep.
But so I believe I can have an app that communicates directly with a phone service. Is it possible to
No,
use
I
that?
meant to say that. No, you can't do that.
Okay.
So the system services are gatewayed, so you can't call them directly from applications. So the stuff I did from the command line works fine from the command line. You can't do that from an app.
Is that because of the permission?
It's ultimately because of the permissions. Yeah, you don't, in a regular app, you don't have the permissions to send messages to daemons. Basically, regular apps just can't send messages to system services.
Okay.
So sorry about that. You'd have to write a system app to do that. Okay, time for one more? Yeah, okay. Yeah, no? Ah, yes, sir. Oh, okay, wait, microphone.
Sorry, thank you.
Great.
So how difficult would it be for like developers like us who do apps to like modify the system so that we can do custom calls that we really want to make our lives better, right? So like being able to quickly change your locale via ADB would be fantastic. How do we do that? Like, not how do we change locale, because I know that's possible, but like how do we, how would we make our own build? Do we really need to build our own AOSP factory.
Kind of, yes. So, I mean, if you want to do fancy stuff, then yes, you will need a user debug build, and you're going to have to either do that yourself, or you're going to have to find somebody who can do it for you. It used to be, by the way, I think until a couple of releases back, the emulator actually did ship user debug builds. So about 4 years ago, they stopped doing that. So the emulator builds you get now with Android Studio are just user builds, and so they're locked down just in the same way as phones are. Can you make your own emulators? Yes. I mean, that's what I did. So this build we are running over here, that's something I did last weekend. It's... I'm going to say it's non-trivial, but it's also, it's not rocket science. It's just a question of typing in the commands. The main snag is that Android builds, AOSP builds take like hours, so expected to take 2 or 3 hours. Okay, I think we're done. So thank you all very much. Been great having you here.